Hi, welcome to my channel, JaberTime. Solve by factoring, and we're going to learn some factoring techniques. The example right here shown on the slide is about factor by grouping. Let's get started. Factoring techniques. Greatest common factor. 2a to the 4b to the third plus 6ab. They both have a common factor between the numbers 2 and 6, which is 2. And between a to the 4 and a, we could factor out 1a. Between b to the third and b, we could factor out 1b. So if we factor out 2 from both sides, we'll get 1 on the first term and 3 on the second term. But I do have a typo. I noticed that, and it's kind of hard to go back and redo it. So let's just jump into it. So 1a, 1b, that I could factor because this could afford 1a and this could afford 1b. That's what we have. Between 2 and 6, we take 2. That's a 1, and that should be a 3. Difference of two squares. That's how we factor difference of two squares, which is a squared minus b squared equals a plus b times a minus b. And now we're going to talk about the sum of two cubes. And that's how we factor it. Notice that I'm highlighting the negative sign right here. And for the difference of two cubes, the negative sign shows in the first set of parentheses. We're going to use it a lot, so I'm not going to read them now. It's just a reference to tell you what we're going to be using. Perfect square trinomials. A squared plus 2ab plus b squared could be factored as a plus b times a plus b. In case if you have a squared minus 2ab plus b squared, we do have it as a minus b times a minus b. Grouping. Here's a good example, a simple one. Ax plus bx plus ay plus by. Notice that I'm using colors here to highlight and show you that this is one group and this is another group. From these two terms, we could factor out 1x. From these two terms, we could factor out 1y, a common factor y. And this is how we do it. But once we do it, notice that they both share a and b. So that's going to end up x out, a from here and b here, a plus b. And from here, when we take y out, we're going to have a from the first term, as this is my first term and this is my second term, b from the second term. But notice that they both have a common factor now, which is a and b. So if I factor a plus b from the right side, I end up with a plus b times x and y, or differently a plus b times x plus y. Here's an example. That's not by grouping, but referring to the factoring techniques, we have different examples. Let's look at this one. 8x cubed plus 125y to the 12. Notice that 8x cubed and 125y to the 12, they're perfect cubes. How is that? 8x cubed is 2x times 2x times 2x. So it is a perfect cube. 125y to the 12 is 5y to the 4 times 5y to the 4 times 5y to the 4. So we could look at both as perfect cubes, and we're looking at a sum of two cubes. So now the way we are looking at it, this is like my a to the third plus b to the third. That's called sum of two cubes. Bring the formula back down here. Keep in mind the minus shows up here. In this example, this will act like my a cube, and this will act like my b cube. So just applying this formula, we're going to have two sets of parentheses, one short, one long. A plus b here, that's my a, that's my b. And that's what I'm saying. A and B, A plus B for the first one. And the second one will be A squared. That's my A, 2x. You square it. Minus, multiply A and B. That's my A. That's my B. Just multiply them. And this is my B. That's going to be B squared. Simplify. And for example, 2x to the second will be 2x times 2x, which is 4x to the second, as you could see right there. And that should do it for this problem. I'm writing the notes to save you some time and give you enough examples instead of 1 or 2 examples. You could pause the video and look at the notes if you need to write something down. But let's keep moving. Here's another example. To factor this, I could see it's a difference. But before I start, I think they do have common factors. Whenever you have common factors, I would say factor that common factor first. So, 54 and 128, they both divide by 2. X to the fifth and x to the second. I could factor out x to the second. As you could see, 2x to the second from both. So what's left here is 27 times 2 is 54. That's 27. And x to the second times x to the third will take me back to x to the fifth. 128, take 2 out as a factor. That's 64 now left for me. Take x to the second out. There is no more x to the second right here. Now looking at this right here, that's a difference between 27x cubed and 64y cubed. Let's see if those are perfect cubes. So we could look at this as a difference of perfect cubes. 27x to the third is 3x times 3x times 3x. So it is a cube. Looking at 64y to the third, that is also a cube, or perfect cube. 4y times 4y times 4y. So with that, we are looking at it as difference of 2 cubes. These 2 terms. The formula, I'll take it back to you right here to show you. So the minus shows up front, a minus b times a squared plus ab, you multiply a and b, then you square b, and that's how you do it. So let's apply this to the second set right there. 2x squared stays. So we have a short one and a long one. That's a short one, long one. We just apply it, just knowing, identifying what's a and what's b. So today, this is my a, 3x. This is my b, 4y. So that's a minus b. A squared, b squared, a times b. Take a look, see if it makes any sense. That's my b, b squared, 4y to the second, b squared. That will be 16y to the second. And as you could see right there. And 3 times 4 is 12, x times y is xy, 9, x to the second. That's another typo. My mistake. Trying to finish 2 videos, and I ended up with some mistakes. This is 3x, yeah, that should be x to the second, by the way. It's about 6:52 a.m. and I've been awake since actually 2 a.m. finishing my notes. I think that should do it for this problem. Just make a note that there's a typo right here and there's a typo on the first slide. Hopefully there is no more typos. Let's keep going. Factor by grouping. Now if you notice right here, we have x to the second, we have x to the second, we have x to the second. And this term has a y, this term has a y, and this term has a y. which means I could look at the x to the second terms that they have x to the second together. I'm underlining them in black, and the terms that they do have y's, I underline them in green to see it in a clean picture. I'm using now colors. Those three terms, they go together, and those three terms, they go together. So from these terms, we're going to factor x to the second. Of course, looking at anything else, a and b and c, no. 14, 28, and 35, they both could afford a 7 as a common factor. 14 divides by 7, 28 divides by 7, and 35 divides by 7. So we're going to take also 7 out. From this right here, we're going to see 8 and 16 and 20. They both divide by 2. I could see that. But they all actually divide by 4. 8 divides by 4, 16 divides by 4, and 20 divides by 4. So we're going to take 4 out, and we're going to take y out. Since I have a minus, I'm going to take the minus. So I'm going to take minus 4y. Here we go. So 7x to the second out. Multiply by 2a to see if this works. 7 times 2 is 14. X to the second times ax to the second. 7x to the second times 4b will be 28 bx to the second, which is right there. 7x to the second times minus 5c will be negative 35 cx to the second. Good, no typos. This one right here, we said we're going to take minus 4y. So minus 4y times 2a will be minus 8ay. This right here will be minus 4 times 4 is 16. Yes, y and b. The last part will end up minus 4y times minus 5c to take it back to positive 20cy, which is good. Now, looking at this right here inside parentheses and this part inside parentheses, I notice that they're both the same, except they're different colors. So we're going to factor it out from both terms. This long term and this long term, they both have a common factor. By taking it out from here, we have 7x squared, and from here we have minus 4y. That should do it for this problem. Let's take another one. Now this one right here, 64x to the 6 minus y to the 6. Looking at each term by itself, I could see that the 64x to the 6 is a square, a perfect square. 8x to the third times 8x to the third. And y to the 6 will be y to the third times y to the third. So we're looking at difference of two squares. We have a formula for difference of two squares. A squared minus b squared gives me a plus b times a minus b. We're going to apply that. And now I have a, that's my a, inside a plus b times a minus b. Now, the 8x to the third could be looked at also as a cube, which is 2x times 2x times 2x. So the problem turns now to a sum of two cubes and a difference of two cubes. The formulas are as follows. They look alike except the minus here for the minus, and the minus shows on the second part, first spot, when it's an addition. For the first part, we're going to use this. For the second part, we're going to use the difference of two cubes, knowing, of course, what's my a and what's my b. In both cases, a is 2x, as you could see, and b is y. So here we go. That's the sum of two cubes, and that is the difference of two cubes. just apply it, and that should do it. Let's take another example. Solve by factoring. 4x cubed plus 12x squared minus 9x minus 27. What do you think? They don't all have anything in common as to take out. 4 is even and 9 is odd. So I can't take something out as a common factor. But here's another way. 4 and 12, they do share common factors. 9 and 27, they do have common factors. So I'm going to use by grouping. From the first two terms, we're going to take 4 out between 4 and 12. And we're going to take also the highest number of x's that we could take out, which is x to the second. From the second part, we're just going to take 9 out. We'll take the minus also to keep it positive inside. So we have 4x to the second multiplied by x to take it back, and 4x to the second times 3 to take it back to 12x to the second. Minus 9 times x and minus 9 times 3, which is minus 27. Now I do have x plus 3 here and x plus 3 here, so we're going to factor that out from both terms. From here we have 4x to the second, and from the second part we have minus 9, as you could see. But that's a difference of two squares. Let me show you why. The a will be 2x and the b will be 3. 2x plus 3, just like this, and 2x minus 3. That's my a, that's my b, a plus b, and a minus b. Of course, we leave this right there. Now, we have another principle, or a principle that I did not mention on the first slide, or second slide. It's called the principle of zero products. When you apply a times b, and you end up with 0, that implies either a is 0 or b is 0. So, we have a times b times c equals 0 now, which means either a is 0 or b is 0 or c is 0. And that's what I mean. We're going to add 3 here to both sides. We're going to subtract 3 from both sides. We're going to subtract 3 from both sides here. This cancels, and we're going to end up with 2x equals negative 3. Here cancels, 2x equals positive 3. This cancels, x equals negative 3. Divide by 2 here, divide by 2 here. This is done, and that should do it. So negative 3 over 2, positive 3 over 2, and negative 3. That's when it says solve. So when it says solve, you need to finish it because we do have an equal sign here. It's not just an expression to simplify. Okay, we're almost halfway. Actually, a little bit more than halfway. Moving on. Trying to save you some time, guys, by not recording 40 minutes. And hopefully I won't go up to 40 minutes. My plan is like about 35. Let's keep going. Factor completely. 8c cubed minus 27d to the third. What do you think? I think we're looking at cubes and a difference of 2 cubes. Let's take a look. 8c to the third is 2c times 2c times 2c, and 27d to the third is 3d times 3d times 3d. So we're looking at difference of 2 cubes, and the formula, which we have it before, again is right here. You just need to identify what's your a and what's your b. In this case, to apply this, a is 2c and b is 3d. So just apply it, and here's the right hand side, the minus in the first set of parentheses. That's my a, that's my b, a minus b, I think that's a squared, that's a times b, and that's my b square. Simplifying, that's 2c times 2c, which is 4c squared. This time I did not have a typo. 2 times 3 is 6, cd, 3d times 3d will be 9d squared, and that should do it. Another practice for factoring. Notice before I start factoring to think about cubic or a sum of squares, a difference of two squares. We have common factors between the x's. We could take one x out, as you could see. Let's take it out. Now we have a sum of two cubes. So let's identify these as two cubes as a cube plus b cube. The first part, 64x cubed, is actually 4x times 4x times 4x. So that will act like my a cube. A is 4x. And that will act like my y. Oh, my b. Y is b. And 4x is a. Using this formula, a sum will start with a plus. The minus shows up here. My a is 4x. My b is y. So that will end up as 4x plus y. Let's double check. Yes, 4x plus y. That's a squared. Yes. And that's a times b. A times b multiply 4x times y. That's 4xy. And b squared goes right there as it shows, which is y squared. And that should do it. Now, this is a little bit lengthy, and I have two different ways to do it. Let me show you how. So, by factoring a to the second first, because that's the best way to do it to start, I could see a to the 6 minus b to the 6 left for me. I could look at this as two different ways. Here's one way. I could look at this as a cube, and this is as a cube. B to the second times b to the second times b to the second. Same idea right there. Then I'll use the difference of two cubes. Difference of two cubes. Now in this case, a squared will act like my a, and b squared will act like my b. So I have the formula, and minus in the first set, plus plus in the second set. That's my a, that's my b. That's my a, which is a squared. My b, formally it's called a minus b, but today that's my a under the cube, and that's my b under the cube. Simplify this, and that's what we have. A squared minus b squared will give me a difference of two squares, a minus b times a plus b. And a to the second will be a to the 4. A to the second, b to the second will be just a to the second, b to the second. B to the second will be b to the 4. That's it for this one. But here's another way. Same problem. After you factor a to the second outside, instead of looking at this as difference of two cubes, I'm going to look at it as difference of two squares. So a to the third times a to the third will take me back to a to the 6. Same thing for b to the 6. I'm going to look at it as a square now this time. You know, you could have it b to the third to the second instead of b to the second to the third. So now we have difference of two squares. And difference of two squares will be factored as a plus b times a minus b. Plus and minus. That's the difference of two cubes. That's the sum of two cubes. We have them. We apply them. Same idea. And that's what we have. Now, if you simplify this, or put this next to this one to make it look alike, like this left-hand side, I end up with the following. But you might say like, so if we have different ways, we have different answers? No, of course not. That should be the same or equivalent to this. It doesn't look like it, but I'll show you why. they are both equal. Let's take this to the side. A to the 4 plus a to the second b to the second plus b to the 4, and ensure that it equals this product, because before that we have them the same. This was replacing, or should be equivalent to these two multiplied. Here we go. So let's take those and multiply them. A good way to multiply them is not distributive, because distributive will take you too long to multiply and it's going to be lengthy to display. Let's use the box or the rectangular method. On one side of the rectangle, we're going to go a square and ab and b square. On the other side, we're going to take a square minus ab and b square. Just multiply and take your time. For example, this is a to the 4, as you can see, from a to the second and a to the second. This right here will be a to the second times ab, which is a to the third b, and so on. After you finish, I could see that this cancels that, this cancels that, and this cancels that. So I end up only with this, this, and this, which is down below. And that's what we had on the previous slide. I'll take you back to show you. Multiply these two, it should equal this right here. And that's what we have. We multiplied these two, we came up with this, and we should be fine. So either way is fine. Another example. Could we factor something out as a common factor? What do you think? I think we take one a out, right? They all have a's in it. So let's take one a out. So we have a to the second left for me here, 9a from the second term, and 14 by itself on the third. To do that, just regular factoring technique, two sets of parentheses for this part. 14 comes from 2 times 7, both negatives to give you positive 14, and negative 7a and negative 2a will add up to negative 9a, so we are fine. That's how we factor it. That gives me three options. The principle of zero products tells me either this 0, or this is 0, or this is 0. So a equals 0, or a minus 7 equals 0, or a minus 2 equals 0. Add 7 to both sides here, add 2 to both sides, and finish it. So you have a equals 0, a equals 7, a equals 2. Next example. To factor this, you could start with two sets of parentheses. Probably 81 will be 9 times 9. And those two 9s will add up to 18. So that should do it. Or you could use directly a formula that is a perfect trinomial. This right here comes to a plus b to the second, and this is exactly like ours, knowing that a is y and knowing that b is 9. So we have 2 times a times b, 2 times 9 times y, which is 18y. So by doing that, a is y and b is 9, and that's what we have. Y plus 9 to the second. We want to make it equal to 0, and that says y equals negative 9. One more. We could factor something out. We could take x to the second out, but between 19 and 38, they both divide by 19. So let's take 19 out. 19 and x to the second out. With the principle of zero products, either the first is 0 or the second is 0. Divide by 19, add 2 to both sides. I get x squared equals 0, I get x equals 2 and final answer. And that should do it. It's about 33 minutes. Thank you.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.